My name is Braden Goddard, and I am an assistant professor in mechanical nuclear engineering here at Virginia Commonwealth University. And my laboratory here is focused on nuclear security and non-proliferation. So think of bad people out there, terrorists and enemy countries, and they want nuclear and radiological weapons. My research is to stop them and train students to work for other organizations to stop them. So my students will go and work for FBI, CIA, but also research laboratories, Oak Ridge National Laboratory, Los Alamos National Laboratory, and they'll develop new science and techniques to be able to detect illicit radioactive materials. So how do we detect it? So we have various detectors in here. I have all kinds of different radiation detectors to detect the radiation that's emitted and be able to say this is radiation from a weapon and this is radiation from a medical procedure. We also will do things where we'll take some kind of flying device, a UAV, we'll attach a radiation detector to the bottom of it and then fly it around, and then you can search for radiation that way. So think of inauguration, Olympics, big gathering places, which we're currently not doing yet. Thank you, COVID. But we'll search those locations and see if there's someone in there with a backpack that we don't like. What students do, actually had a team of students that they were connecting a radiation detector to this, and so we were worried that if it crashes, it'll break our $10,000, $15,000 detector. So they actually designed and manufactured a case so you can drop it and it doesn't break. Other things we do in this lab, we do a lot with radiation measurements. Here, this is actually a really cool thing that we were doing, is a filter company said, hey, I have this filter and we can filter out lead, which is great. I don't want wet lead in my drinking water. But they discovered they can filter out other things, such as natural uranium. And so they said, hey, our filters are so good, they're going to get a lot of uranium in it. Does this become a radiation hazard? Do we have to dispose of this waste specially? And so they gave us a sample and we measured it and did all the assessment to figure out how much uranium is in their filter when it's all the way saturated. And does that have to be treated as radioactive waste, or is it low enough that you just dump it in the trash? So that's kind of the cool things we do in this lab. It's a combination of physical measurements with radiation detectors, building systems, shielding sources. We get to play with cool things. Here's some metallic uranium. Yay for that. And then we do a lot of modeling. So you notice that sample is a couple grams. In real life, I'm not worried about a couple grams of uranium. I'm worried about kilograms. They don't let me have kilograms of weapon-grade uranium in this building. So we will model it. So it's a combination of modeling and experiments, and the students that graduate from here have a diverse set of skills, and they have no problems finding employment. Any questions?